Hi folks, I was planning on just putting up a couple of the CodingBat examples and just show you how I normally start working my way through these and finding a solution and making that solution more elegant as we go. Most of you probably aren't at the CodingBat assignments yet, but when you get there, hopefully this will be of some assistance to you. When you're in CodingBat, first off, make sure you've got an account. It'll ask you to sign in every time you come in, and it'll let you create an account up here in the right corner. Second, make sure you're not in the Java section, because that'll make very little sense to you since we're not doing Java, so make sure you're in the Python section. I'll just start with warm-up 1. You won't be able to do too many of these unless you're at least past 4.3 and 4.4, because you're going to need to understand functions very well, and you're going to need to understand if statements and conditionals very well. And I know you've done it in Reborg, but you may have not done it in Python yet, so definitely go through the 4.1 to 4.4 videos before trying these. The string stuff, you probably aren't going to tackle until you've got past 4.6, which is strings. Logic you should be able to do. And anything that says list, that I think is 4.7. So after you're done 4.3, 4.4, you can probably do the warm-ups. As indicated, you don't have to do every single one of these. I made a list, and it's on the Blackboard website of which ones you need to do. So don't do all of them. Also, you don't have to send me your code. You actually just have to go into each particular section and then just take a screen capture or a picture of these with the check mark so that I know you've done it, because you can't get the check mark unless you actually complete the program. So I'm just going to start with the first one on the warm-up list here and give you a little example of how I would tackle this. And I should, that's my solution, but I should let you know that some of these have a show solution and some of those don't have a show solution. So the show solution gives you the optimal code for it. But the way I normally tackle these is I normally just kind of try to solve it situation by situation, get everything working, test my code, get everything working, and then after that, I'll look at my code and see if there's ways that I can make it more efficient and more elegant. And typically, you want your code to be as short as possible while still accomplishing everything that you need to in the program. So this is how I would tackle these. Everything is based on functions. So what you see here is just examples. So what CodingBat is telling you here is that if I try to run the function sleep in, and I give you two values, false and false, both of those are Boolean, your program should return true. So because we're returning values, every single one of your functions that you build in CodingBat has to be a fruitful function, and that's in 4.3. So make sure that you understand the difference between a void function and a fruitful function. So this is sample data. This should give you true. This is a different one. This is a second scenario that it could possibly give you. This is what it should return, and same here for the third one. So I usually just go through the code, and I'm a fan of kind of just throwing stuff at the wall and seeing what sticks. So I'm a fan of kind of going through these one at a time and then checking it, and then over here it'll tell you how many situations are correct and how many situations are incorrect, and then I just improve my code based on that. So let's start right now. I know that I need to have a function that's called sleep in, so I'm going to define a function. Make sure I'm in the code window here. Define a function, and it has to be the same name, right? Sleep underscore in. They use snake case. And I know that it needs to take two values. It needs to take whatever's first and whatever's second. So you can name those variables whatever you want. They're going to be local just inside the function. And again, if you go through 4.3, you'll know the difference between a local variable and a global variable. I don't think I need global variables for any of these, but we'll see. So I've got a function, and I know it needs to accept two things. So it's got to accept two pieces of data, and I can name them whatever I want, but let me just check here. Parameter weekday is true. If we are on vacation, if we sleep in, we sleep in if it's not a weekday or a vacation. Return true if we sleep in. So this is, I think, the weekday part, and this is the vacation part. So maybe I'll call the first one WK for weekend, and maybe I'll call the second one VAC for vacation. It doesn't really matter. You can name those whatever you want. Now, what needs to happen? Okay, so what needs to happen in this variable is if I get a false and a false, it should return true. If I get a true and a false, it should return false. If I get a false and a true, it should return true. So what I'm going to do is I'm just going to start with this first scenario, get that one working, and then I'll worry about the other two. So it's conditional. Obviously, it's conditional upon what they send us. So if Codian. So it's got to be an if statement. If WK, I should put these in brackets. I always put my logic in brackets. If WK equals, let's say false, because that's the first set of data they're giving us, and, vacation, so VAC equals false, okay, then I return true. Okay, so this basically takes care of this first line. Okay, if it's a weekday, and if I'm not on vacation, I am sleeping in. That's what the true means. So this is what you're supposed to return. So that's why I'm returning true. So if the weekend is false, sorry, and the vacation is false, yeah, so if it's a weekend or if I'm not on vacation, I'm sleeping in. That's what the true is. So now I'll just run my code, and it's going to show me, okay, we put in all of this data. Okay, we tried the program once, we tried it twice, we tried it 3 times, we tried it 4 times. It only worked on this one condition, and it did not work on these other conditions. So I know I've started the process correctly because I took care of this one. Okay, so now, why don't I just make another if statement? And this is normally how I start, with a bunch of ifs and elifs and elses, and then eventually I'll try to pare that down and make it more effective. So if, let's say, if it's the weekday equals true, okay, but, sorry, if it's a true weekday, okay, when I do equals, I need to do 2 equals true, and if the vacation is false, which means I'm not on vacation, so it's a weekday, let's say it's Monday, and I'm not on vacation, I'm not sleeping in, so false to sleeping in. And now I can run, false, and now I can run my code again, and, oh, I hit the solution one, sorry, line 4, 1, 2, 3, 4, elif, and vacation, oh, vacation equals false. Okay, now I run my code, and I've got both of the first 2 handled, and I don't have the other 2 handled. So I can do another elif. Remember, it'll only run one of these, right? If it runs the first one, it won't run the rest. If it runs the second one, it won't run the rest. So it only is going to run one of these. That's part of being mutually exclusive, is it's only, it either runs or it doesn't run. There's nothing in between. So what's my third scenario here? What the other possibility is, what if it is... Okay, what if it is not a weekend? So if the not a weekday, so true. Sorry, that should be false, my bad. So if it's not a weekday, that means it's a weekend. We know already I'm sleeping in. So it doesn't matter. I can include the other vacation part, but we know that if it's a weekend, I'm sleeping in for sure, right? So I don't even need the second part of my logic. I know I am sleeping in, so sleep in is true. And then our only other option, else, the only other option left, because this one takes care of a weekday and no vacation. This one takes care of a weekend and, a weekday. Yeah, sorry, this is a weekend. My bad. This is a weekend, and this is a vacation. So should be true if it's a weekday, and the parameter vacation is true. We sleep in if it is not a weekday or if we're on vacation. So actually for this one here, I didn't need the second part of the logic. I'll just quickly explain that. Maybe I'll start from the top down again just to make sure it's perfectly clear. This indicates whether it's a weekday or not. This indicates whether we're on vacation or not. So if weekday is false, that means it's a weekend, which means I'm sleeping in. Okay, the next one, it's a weekday, so it could be Monday, Tuesday, Wednesday. But if it's Monday, Tuesday, Wednesday, and we're not on vacation, we're not sleeping in. Now, if it is a weekend, I already took care of that one up here, so I can change this one. So why don't I change this one? If we're on vacation, it doesn't even matter what day it is. If we're on vacation, I'm sleeping in. So that should be true. So I actually don't need the else on this one. I just need the else there. So there's only really 3 conditions that I can see on this one. Only 3 possibilities. Either it's a weekday and I'm not on vacation, so I'm not sleeping in. It is a weekend, so I'm sleeping in. Or I'm on vacation and I'm sleeping in. So let's see if this handles all of the cases. Once again, syntax error, line 6. 1, 2, 3, 4, 5, 6, else. Vacate. Oh, you never have to have logic for your else. Your else is always just by itself, because whatever you put down here, you should have taken care of all the situations up here. So if there's only 3 possibilities, it's either 1, 2, or the else. The else is kind of the catch-all at the end. So let's just have a look here. Okay, so we did. We took care of all of the situations. Okay, if it's a weekend, we're sleeping in. Okay, if it's a weekday and we're not on vacation, I'm not sleeping in. And the only other option is it's a vacation day. I'm on vacation. So I could have put if vacation equals true in another if statement, but really it's the only other option. So I just put it as else turn true, because I know if I get down to this point, I'm on vacation. I know that based on what I've done above it. So, I get the all correct on that one and I'm good to go. And then you can just flip to the next one. All right, so let's have a look at this one. Oh, and when I go back, I would try to make this as small as possible. So this was my final solution. The solution that I gave you in the video here just a second ago was longer than this. Not a whole lot longer, but it was maybe a couple more lines. So I just, when I did this the first time, I called one variable weekday and the other one vacation. So I just used different variable names. And I managed to figure out that if I use a not statement, if it's not a weekday, or it's a vacation, okay, I'm sleeping in. Any other case, I am not sleeping in. Okay, so I managed to take my code and do the exact same thing with my code in only 4 lines instead of 7 lines or however many I had. And ideally, your solution here, when you check the show solution box, ideally your solution is about the same size or maybe even a little less than that. So my solution was, at the end of the day, it was pretty much exactly the same. So that one was okay. And let's do the next one. Just keep rolling here. So what do we got here? We've got a function that's named monkey trouble. And it takes 2 pieces of data, and they're both Boolean. Okay, so this is either going to be true or false, and the second one's either going to be true or false. We got monkey A, monkey B. Okay, the parameters A smile and B smile indicate if each is smiling. Okay, so this is actually a smile and B smile, but you won't need to put that in your code because it automatically sends it. So indicate if each is smiling. If we are in trouble, if they're both smiling, or if neither of them is smiling. So we're going to return true if we're in trouble. Are we in trouble? True is yes. Are we in trouble? False? No, we're not in trouble. So let's look at these scenarios and let's build it piece by piece again, and then at the end we can make it more efficient if we want. So we know we need a function. We always need a function for these, and we know what it's named because they tell us right here. So it needs to be called monkey trouble. Make sure you get underscores and everything exactly the same. It takes 2 pieces of data, right? So there's monkey A. Call it A smile, or you just call it A. It's monkey A and monkey B. So we take in 2 pieces of data, and we know those pieces of data, A and B, are either going to be true or false. So what happens here? If they are both smiling, that would be true and true. So are we in trouble? Yes. So let's take care of that first. If, okay, A, put it in brackets here because I like using bedmass just in case. If A equals true, okay, and B equals true, so that means both monkeys are smiling, then we need to return true because we are in trouble. Okay, what is another option? Elif. Okay. We could do elif, which is else if A equals true. Okay. Let's see, A equals true. And B equals false. Okay. Or I should do this. I should actually do this a little differently here. If monkey A is not smiling, okay, and monkey B is smiling, okay, so if A equals false, or are we in trouble if neither of them smile? Yes, we are. Okay, so let's take care. We took care of them both smiling here. Now let's take care of them both not smiling. So that shouldn't be an or. That should be an and. So if monkey A is smiling and monkey B, is not smiling and monkey B is also not smiling, okay, then we are still in trouble, right? So we should return true. The only other possibilities are that one or the other is smiling. So I don't actually have to have any more logic. Okay. So the only two that really matter to me is, are they both smiling? If so, we're in trouble. Are neither of them smiling? If so, we're in trouble. So the only other option is one is smiling and the other isn't smiling. And it doesn't matter if A is smiling and B is not smiling, or if A is not smiling and B is smiling. It doesn't matter, because both of those result in false. So it doesn't matter if it's true, false, or if it's false, true. That's going to end up in false. So I took care of the two important ones up here, and the only other option is that we are going to return false. We are not in trouble because we know that one of the two monkeys is smiling. So if I go check this out, it passed all the tests right away. Now what I could have done on this is, I just cut this out for a second, I could have done it one at a time. I could have checked, is this part working? Okay, that part's working. And then I could have added in a little more, right? You know, maybe if I take this last chunk out, is this working? Oh, this would need to be an else. Sorry. No, this would need to be another if statement. Anyway, the point is, excuse me, the point is you're checking them sort of one at a time. I checked them, I kind of went through it all at once and solved the problem. I'll just go back to my original solution. There we go. So this was my original solution. I tried to take care of everything all at once. I tried to take care of all four of these possible scenarios, both smiling, both not smiling, smiling, not smiling, and not smiling, smiling. I took care of them all at once, so the first time I ran my program, I got the right answer. And the only reason that's not working is because of white space. So that's the process I normally take on these things. I just very carefully read what the input's going to be. So this is what the computer is going to give me. It's going to access monkey trouble. It's going to give me two pieces of Boolean data, either of which could be true or false. And then it's telling me, if I give you the data on the left side, your program should return what's on the right side. So by working through these sort of one scenario at a time, you can pretty quickly go through all these checkboxes. And these first couple programs in the warm-ups, these programs in the warm-ups, they're not particularly difficult as far as logic is concerned. There's only 4 checks it runs or 3 checks that it runs. When you get to some of the later program, you'll have a much bigger list of these things, and maybe you get a bit into your code and you test it, and you'll have a green up here and a green in the middle and a green at the bottom, and the rest are all red. That's okay. I mean, that means you're making progress. Every time you submit your code, every time you hit go, if you've got more green marks than you had the time before, that means you're getting closer to the actual solution. So my recommendation is not to try to solve all of these all at once unless you're really, really good at this. Rather, try to build your way up to the correct solutions one step at a time. So hopefully that helps a little bit, just getting started. And as we go through, if students are struggling with a particular CodingBat example, I might go do another tutorial on something a bit more difficult. In any case, let me know if you got any questions or concerns.